I'm just going to level with you. Your email, it's not safe. Every day, billions and billions of emails are sent across the internet, and they are inherently not secure. By default, email is not a secure mechanism. What does that mean for you and me as system administrators and IT professionals? Well, we've got to figure out ways to facilitate end-to-end email encryption to ensure our data in transit is absolutely as secure as possible. Fortunately, there are solutions available for us. One of those solutions is called GNU Privacy Guard for Windows, GPG for Windows. Embedded in that solution is a certificate manager called Kleopatra. Today, I'm going to show you how easy that solution is to work with, but I'm going to ask the question, could this work in an enterprise environment? Hey everybody, Troy here and welcome. Today I'm looking at a product called Gpg for Windows. Specifically, I'm looking at one of its embedded applications called Kleopatra. My goal today is to determine whether Kleopatra is an easy solution to help me ensure end-to-end encryption for data and information that I send over an email. Along the way, I also want to find an answer to the question, could this work as a possible solution for a business or a production environment? All right, let's dive in. I'm starting at gpg4win.org. This link, as well as timestamps for today's video, in the description below. GPG for Windows is heralded as a secure solution for file and email encryption. That's kind of what I'm looking for. As I dig into the documentation, you're going to see that it has a series of additional components. It has the actual encryption tool, along with the certificate manager I mentioned called Kleopatra. There's a cool Outlook plugin that I can use to integrate with my mail application, and there's also a plugin for Microsoft Explorer. Let's dive in and get this puppy installed. I'm going to go to the green download link on the top right. And because this is for demonstration purposes, I'm going to select the zero donation option and go straight to the download. There's some clarification on how I can check the integrity and accuracy of the download to ensure I'm actually getting the right source files. But now that I got my download, I'm good to go. Before I install the software though, let's pause for a moment and talk a little bit about how Kleopatra works. Kleopatra works on the premise of something we call asymmetric encryption. Sometimes you'll hear that called public key encryption. What this is a special relationship between two keys. We call them a key pair. One we call a private key, and the second we call a public key. Now, these keys are used to encrypt things, and there's a special mathematical relationship between these keys. They work like this. Let's say that I wanted to encrypt a document. So if I used the private key to encrypt this document, the only key in the world that could decrypt it would be the public key. If I did it the other way around, if I used the public key to encrypt this document, the only possible key in the world that could decrypt it is the opposing private key. Now, understanding that special relationship between these keys, what I want to use Kleopatra for is to build a special key pair for Troy. One of those keys is going to be a private key. The second one is going to be a public key. Now, I want to get my public key to Alice. That means that if she wants to send a document to Troy, she is going to use my public key to encrypt it. Once that document is encrypted, there is no way that it can be opened without Troy's special private key. Now, it doesn't matter how many people in the world have my public key. I could have many people having a copy of my public key. In fact, that's actually what I want. What I also want, though, is to safeguard this private key. I need to keep this secure and private so nobody else has access to it. Because as long as that's the case, Alice can use my public key to encrypt this document. And even though half the world could have a copy of this public key, they cannot use that key to decrypt it. The only person who's going to be able to decrypt it is Troy with his private key. So if I do this with Kleopatra, Alice can safely email this document to me as an email attachment, knowing that if anything were to see that email, they would not be able to decrypt that attachment. Now, if I want this process to happen in reverse, that is, I want to send Alice a document that's encrypted. I don't want to encrypt it with my private key because that means anybody with my public key is going to be able to intercept it and decrypt it. So what I'm going to do is I'm going to ensure that Alice builds a special key pair. And I want her to keep her private key private, but I want her to send me her public key. That way, if I use her public key to encrypt this document, I can send it over the email knowing that if it's intercepted, nobody can open it because Alice is the only one who has this private key. So it's this special sharing of public keys that makes this entire process work. Now, how do we share public keys? Well, lots of ways. I could put my public key on a flash drive and give it to Alice. I could put my public key on a server where she could download a copy of it and use it to encrypt documents that she wants to send to me. I could even email her a copy of my public key. I'm not concerned about being intercepted because anything that she encrypts using it cannot be decrypted unless the person has Troy's private key, which I'm going to keep locked away in a safe place. Now, Kleopatra can also use the same public-private key premise to validate or verify that the sender of the information is actually, in fact, who they say they are. When Kleopatra helps me encrypt a document, that encryption is going to include a special provision that we would refer to as a digital signature. That digital signature is going to be created in part using my private key. Now, the only person in the entire world who has the ability to encrypt something using my private key is me, because I'm the only one who has that key. So if this entire package is sent over to Alice, Alice would use her private key to decrypt the document that I sent using her public key. She's also going to be able to use Troy's public key to check that this digital signature was in fact created by Troy's private key. Now, she knows if she can use my public key to reveal my digital signature, she knows that it has to have been created by my private key, thus verifying my identity. Now, that is a tremendous oversimplification of how digital signatures and asymmetric encryption works. I'll try to do a video in the future where I break down those concepts in greater detail for you, but the premise is important for us to understand exactly how we're going to configure Kleopatra. Now, for simplicity's sake, all I'm going to do is I'm going to install Kleopatra on my host machine, and I'm also going to install Kleopatra on a virtual machine so I can have two separate environments to show you how we can transfer encrypted documents. Let's run through the installation of GPG for Windows on my virtual machine. This is a Windows 11 machine. I have transferred the installer to the desktop. I'm simply going to double click and away we go. So it's going to do this setup. It's a fairly straightforward install. I'm going to accept the defaults most of the way. I want Kleopatra. I want the GPG for Outlook, and I'll throw this shell extension in by default with no worries. I'm not going to integrate it into any particular browser at this time. Let's hit next, follow the defaults. Away we go through this process, and that's it. We're done. Well, let's start off by building ourselves some public-private key pairs. I'm going to start off with Alice's environment. Remember, this virtual machine is intended to emulate her workstation, separate and distinct from mine. In her version of Kleopatra, we are ready to create her first new key pair. And I'm going to fill in her fictitious name, Alice Brown. I could put in an email here if I wanted to integrate this with an email client. There's no email client in this world. I'm going to leave her email optionally out. I do know, however, this particular key pair has a private key, and it's pivotal to this security. I'm going to select the protect option to generate this key with a passphrase to ensure that it's challenged every single time we try to decrypt something that's encrypted by this key. I have a chance to look at some of the advanced settings where I get some information associated with the algorithm, the encryption algorithm, the ECDSA, the elliptical curve digital signature algorithm. I'm seeing that I'm using this certificate for signing, certification, as well as encryption. There's a default date 1 year from now, or pardon me, 2 years from now. I'm going to hit OK and create. Challenged with the creation of a passphrase. Now, I would really encourage you to ensure that this is a secure passphrase. I'm going to hit OK, and now I have my key pair created successfully. Good key management suggests that I make a backup of this pair. I'm going to hit this button, and you'll see that I've got an option to save the secret key. This is Alice's secret key of the key pair. I'm going to save this to the desktop. I'm going to input the passphrase that is required with respect to the generation of this. I'll hit OK, and there is my secret key. I could put this on a USB drive. I could move this to a location that's secure for future protection. You see, I also have the option of sending the public key. Remember, I said I got to get this public key to Troy, who's ready to send documents that are going to be encrypted. I could send it by email if I was integrated with a mail application. I could upload it to a directory service. We mentioned that that was an option. I'm going to make it even easier. I'm going to use the old sneaker net where I put this on a USB drive and move it over to Troy. So I'm going to hit finish, and that closes this entire operation. Now, I still need to get that public key. I didn't generate it here. It's in Kleopatra right now, but it's not ready for me to send to Troy. To do that, I'm going to right click on my key pair, and I'm going to choose to export this key, and you'll see that it is now going to export the public key of the key pair to my desktop. I'm going to leave the defaults and click save. And there becomes my key. There it is right there, my public key. Now, when I mentioned SneakerNet, what I'm saying is I'm going to throw this on a USB stick and I'm going to move it to Troy, send it to him, give it to him in the office, whatever. But we're really close in proximity. I'm just going to do a Control-C and a Control-V and put this on Troy's desktop where we'll move to Troy's environment. Fantastic. Let's go. I'm going to minimize Alice's world, and I'm going to pop into Kleopatra that's already installed in Troy's world. I'm going to do the same process that I did on Alice's new installation of Kleopatra. I need to create a new key pair for Troy. Let's put my name in here. Again, optional email. When I integrate this with a particular email client, I definitely would want that in there. I'm going to select my option for protecting it with a passphrase. Confirm my advanced settings. Everything is set there. I'm going to hit create. Challenged for a passphrase. And let's put this in here. We go. And there is my key pair. Let's do the same thing I did with Alex. Good practice. I'm going to back up this key pair, and I'm going to, there's my secret key right there. Fantastic. Need to get my passphrase in there. And my key pair has appeared there on the left side. I've got Alice's public key, and I've got Troy's secret key. Now, let's hit finish, and let's export Troy's public key. I got to get that to Alice. I'm going to right click again on my key pair. I'm going to export the public key of the Troy key pair. I'll save that to my desktop. And there it is right there. There's my public key. Fantastic. So these are my public and private key for Troy, and this is my public key for Alice. Well, it's not doing any good sitting over here. I've got to get this installed into my certificate manager. So what I need to do is import this so Kleopatra can verify it. Well, I can click on the import button right here, navigate to it in File Explorer, or better yet, let's right click on this particular public key and look at here. I've got integrated GPG options in my contextual menu. I'm going to move down to import this key, and it confirms one certificate is being installed. There's Alice's certificate. Now, important to note, if I expand this window here, you're going to see that this is showing as not certified. Now, this is one of the caveats associated with this program. Kleopatra doesn't know where I got this key. It's relying on me to validate or certify this key, which is me essentially telling Kleopatra that I know this key came from a valid source. In order for me to certify this, I simply have to right-click on Alice's name, and I'm going to certify this particular key. I'm verifying it with my own key. I'm certifying that this public key came from a safe place. I'm going to hit certify. Challenges me for a pass code. This is my passphrase that I use for my authentication, and I'm going to hit certification successful. Okay, away to go. This is now certified. Fantastic. Now, I'm not done yet. I still have to get my public key to Alice. Well, remember, I exported it right here. This is my public key. I'm going to do a Control-C. I'm going to go back to Alice's world, and I'm going to paste that onto Alice's desktop. This is Windows 11, but I still have my contextual options. I'm going to right-click on this public key, go to Show More Options, and there is my More Options. Now I can import it into Alice's certificate manager following the same procedure that I did before. Same thing applies. Alice needs to certify to Kleopatra that she got this key from a valid place. She's going to right-click on my name and certify that this particular public key came from a valid source, and she's going to confirm that with her passphrase to complete that certification. We're ready to do some amazing things now. Let's do some encryption. Here's what I'm going to do. I'm going to send a document to Alice. I'm going to minimize Alice's world, and I'm going to start with my own. What I'm going to do first is create a super secret document, something that has to be encrypted because it's very dangerous if it were intercepted. I'm going to right-click, create a new text document. I'm going to call this super secret stuff. There it is. Inside my super secret stuff, I'm going to put important information. There it is. I'm going to do a Control-S, save, close this up. This is the document that I want to send to Alice. Now, before I do this, I want to encrypt it so that only she can open it. And I'm going to use her public key to do so. Now, I could use the sign and encrypt option right here on the top left. What happens when I open this up takes me to my Windows Explorer. I could navigate to that particular document. But right-clicking is my friend. I'm going to right-click on this document, and I'm going to go to my Gpg4Win options, and this is what I'm going to do. I'm going to look at these options. I can encrypt it using her public key, and I can sign it using my private key to verify the identity of the sender. I'm going to do both, sign and encrypt. Nice. Now, I'm going to sign it as me. I'm using my private key for this because I want her copy of my public key to validate that I'm the only person that could have signed this. There are, in fact, no other options here. I also have the option of encrypting this file for my own local environment. If I wanted to, I could encrypt it for my area in the event maybe this was a shared computer or I wanted to ensure that this document couldn't be seen by anybody who might be using my computer. I'm not worried about that in this point. I'm going to uncheck this box and I'm going to encrypt it for Alice only. The way I'm going to do that is I'm going to click on this option on the right, Show Certificate List, and I'm going to find Alice's public key, and I'm going to hit OK. Now, see that I could also encrypt it for other people if I had multiple public keys here. I only have the one, and I'm going to expect that there's an output, a special encrypted file that's going to land on my desktop based on the name that I gave that original document. I'm going to sign and encrypt. It warns me that says, hey, you know what? You're encrypting this with only public keys that aren't yours. You will not be able to open this, Troy. And I go, I know. I have the original. I'm fine with that. The document that is as a result of this is only for Alice. I will not be able to open it again. But I'm fine with that. I'm going to hit continue. And I have signed it and encrypted it all successfully. There it is right there. There's my new encrypted document, super secret stuff.txt.gpg. Now I can verify that I can't open it. I don't have the key to open this. I can double click it and you'll see that Kleopatra tells me, no, you can't decrypt this, Troy. You do not have the correct key for this. The only key that I have was Alice's public key. It's only going to be openable by Alice's private key. But now I'm good to send this to Alice. I could send this as an email attachment, knowing that even though, despite the limitations of email, if somebody were to intercept it or see it, they're not going to be able to open that attachment. But even easier, what I could do is simply Control-C, throw this on a USB stick, and I'm going to go back to Alice's world, and I'm going to put this particular super secret encrypted document on her desktop. Now I know that Alice is going to try to do two things. First off, what she needs to do is verify that I was the sender, but she also has to decrypt this using her private key. Now that's simple. I can decrypt and verify by navigating to the file through the File Explorer option right here, or I can right click, and again with Windows 10 I got to go into the Show More options. Let's look at my GPG-EX options and let's decrypt and verify. So here we go. The verification worked. You can see that Kleopatra has found that she can verify that the signature was created in fact by Troy. The way we're able to do that is Kleopatra is using my public key to open the private key encrypted signature file that's inside this package. Green tells me it's fully trusted. I'm going to hit save and let's see what happens. There is my super secret decrypted file right there. So this is now what was sent. I can open it up. It's ready for me to do anything I want with. Alice can see every important piece of information inside there. Now, before we wrap this up, I do want to show you the Outlook integration of GPG for Windows. Remember, when I did the installation, I told GPG to include something called the Gpg4Win plugin, the GPG Outlook plugin, and it seamlessly integrated with my version of Outlook 2021. Now, remember, if I were sending something to Alice via email, it's probably sufficient for me to attach it as an encrypted attachment. The problem with doing that alone is that nothing in the body of my email is encrypted, which is fine if I say something like, please see document attached, and the document isn't fully encrypted, I'm probably safe. But if I were putting sensitive information in the body of my email, simply adding my encrypted attachment isn't enough. This is where this Outlook plugin comes in. I can use this plugin to digitally encrypt the contents of the email in addition to signing my email using the digital signature included in Kleopatra. Now here's the kicker. The only way this is going to work is if Alice or my recipient also has this particular plugin attached and included in Outlook. However, a simple, easy drop-down menu to encrypt my contents of my email, giving me true end-to-end encryption. Awesome. So now we've seen Kleopatra Certificate Manager showing us how we can use the public and private keys that we embed in our manager to encrypt and send documents back and forth to another party. That's cool. It was actually ridiculously easy once we figured out that whole public-private key thing. But would we possibly consider putting this in a production environment? Well, if you asked me, the answer would be no. I couldn't see using this in a large infrastructure. There's a lot of problems here that we would have to overcome from an administration point of view. First off, a user has to understand how public and private keys work. There's a training element there, and lots of users won't have that ability to grasp that on the first try. Secondly, it doesn't scale all that well. Remember, for every recipient I want to send documents to, I need to have their public key in Kleopatra so I can encrypt it so only they can open it with their private key, which means there's a lot of key management going on. My example was between Troy and Alice. Those were two individuals. Imagine if Troy needed to have public keys for 200 fellow employees. Well, that's a lot of keys. And third, there's a lot of really good alternatives out there. If we're using Microsoft 365, there's a lot of embedded tools already that we could probably take advantage of. I've actually put a link in the description below that goes through the most current levels of embedded encryption associated with the Microsoft products. So Kleopatra, you're pretty cool, and I could totally see me using this product if I were in a small group of professionals who were comfortable using this technology. But if you can think of a way to incorporate something like this in a large-scale environment that I can't, I would love to hear about it. I would love to see if there's an alternative that I'm overlooking. Other than that, hopefully this was helpful. I will see you next time. Thanks for joining me.